We're here to talk through the Snake Pit X puzzle by Prasanna Seshadri called Surrounded. It's got these circle rings, but with 4 X clues, and the fact that there are no ends in these spaces are going to be a pretty good tension in each of the corners of the grid. I'm actually seeing in the lower right one quick place that works straight away, and one of the things to keep in mind, I think, when you know where one end of the snake is, you can kind of think of the checkerboard, and you sort of can identify the cells that could be the other end based on the parity. So this needs the cell 2 away from it, which could be this cell or this cell or this cell. This can't be an end of a snake, so this is ruled out, and this can't, because it's touching another 3, be the end of the snake, so this snake has to end here. Only space for it to end, we can get sort of this marked in the grid. This 5 also needs a cell that's in an odd parity away from it. So this cell here could be where this 5 ends, but it would have to come through this other end. That doesn't work. This cell could be the end of this 5, but then would again touch to another end cell, so this is no good. This could work for parity, but it's an X cell. This also can work and looks to be valid. We can't come further out to here. Could we come through the 6? So this is like this cell or the last for the 5. And while you can reach over to them, notice that those cells will always have a bending U-pentomino shape. So the only cell this 5 can end at is this cell. But that's based off the X's in the grid. It's based off the other clues in the grid. But I was thinking through the parity constraints of what we know. The 6 can't come down. So this will have to come up. And so one place I'm seeing the logic I can extend is seeing this comes up. So this 6 always joins here. This will be the 4th cell. So it can't go to the right for a 5th cell. So it has to keep coming up here. So this will be 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, but it's going to have to come to the right to get its 6th cell. And in doing that, we've isolated this cell, so this will take 2, put this down for 2, so we get this finished 6, get these markings. Something I'm seeing then down here, though, is now some more constraints around these X's, so it's probably worth thinking through this now as opposed to later. One thing for sure is we're going to take these 2 cells together. Notice that we're not taking this pattern for the 5, so we're going to take this, we're going to take this. So we always have to take at least these 2 together. The tension I see is when we do this pattern, we have to turn this way through this X. So by the time this X only has 2 options for it, it's got to use both of them. So X's don't have any turning spots. And in thinking through that, what we would end up doing is forcing this 5 to come straight to the left, and it would then be far too small. So this doesn't have this option for it. Again, we have these 2 cells, but they are on their own, and the 5 comes straight down for this to work. Let's sort of continue then on the left side here. So the 6 has to come up. So where can the 6 end? The 6 ends in an even cell, so a cell like this or this or this. So can it end here? No, it's near a 6. Can it end here? No, it's near a 6. Can it end here? No. It would then pass through the 6. This looks like a good cell for it to end at, and I don't see any others that are actually of the right even parity and not touching known digits. So how do I get from this cell to this cell in 6 moves after I've started up? Well, I have to come all the way over to the right and then come down, noticing that I have this edge constraint. So this is from packing through these unusable ends, these X cells, but a pretty fast set of progress here. I see logic with this too that's kind of like the logic we had down here. So again, what I don't want to do is make an X that has to turn quickly, because I then isolate this clue into it. So this 2 can't come down. It has to go to the right. In doing that, we're going to have this cell coming out. This X is going to continue. This 6 doesn't want to come down because it's touching to another 6. If it does that, it can't come to the left. So it goes this way. So this actually closes as a 4. You got another snake going out here. We've got the start here for a 6 clue. We've got 4 cells to here. These are boundaries because now these 6s can't join, but we've got to get a snake through it. So the 6 has to continue down. Makes this. What does that open up for us? Well, we've got some more in the center we can do, and that's tied to these X's. So here's the first thing we know, like this 2 doesn't connect to any of these X clues. It's either down or to the right. We've got an X like this. It can take this edge, but then it always takes at least this edge to the left or takes this edge to the right. That means it's going to be a 4. And if it's a 4, it's got to be 4 all the way. And I see the same thinking actually works for this X clue. This X clue could come up, but it at least has to go left or down, and doing that it's going to become a 3, and because it's surrounded by 2 3s, it for sure is a 3. So we can mark these in. We've got this boundary. We can't end on the cell or end on the cell, so we've got one more cell to take. This looks like the pattern. These 4s touch, so this is not what joins together. The cell and the cell coming together would make this be a 4-unit snake again, so this has to at least go to the right. This has to go to the right. If this 4 comes to this cell, we leave behind 4 in this other shape, which is 2 plus 2 or 4 touching 4. Both of those are bad, so instead this 4 has to come up and take this. Let's get the shape. These two coming down are adjacent to this x. It has to take both edges. This x has to come through both edges too. So this works out. This single cell comes down. If the 4 doesn't use it, then we'd form a 3 here touching a 3. So instead the 4 does use it and closes like this. Get this edge coming down, this edge coming down. This 5 can't join here, so this is over here. If these came together, we'd again put another 4 in the grid, so these come across. Let's see, if this joined to this, would put a 5 near a 5, so that actually isn't allowed. So this is a 3. This must be larger than a 3. So this comes over here. Get the start of this 5 shape. It can't end on this end, so it's got to come to the right. That puts a 2 into this. This could be 4 and 2, but actually it can't join. This x has to come across, so this is a 4 on its own. This is touching to a 4 and 5, so this has to keep getting larger, and it has to take at least this cell and one more. So it can't come up. There's not enough space for it there. The single cell then has to come here because it doesn't want to touch to the 3. So now let's go back to our game of thinking about where do these groups end. This 3 has to end in a cell that's 2 away from it. It can't end here. It can't end here because it's touching a 3. It could end here, and the cell is blocked by a larger snake. So this is the end for this 3. Let's come to this 3. Where does it end? It can't end here. It can't end here because of the end. Touching to a 3, this would touch to that 3. The only cell I see for this 3 to end at is right here. So we can mark that in. And maybe it's a different coloring, so we get this 3 here, but we do know that that circle is not part of a touching 3, so we've got an edge there at least. It's not coming down because the cell will be a 3. I might as well just go to numbers and put 3 right there. Coming to the top, let's think about these 6s. Are these different snakes? They're not different snakes. They don't have room to get out of the grid, so these are the same snake. If they are the same snake, they've got to do something kind of like what we saw on the left side of the grid. They've got to come down to this row and then connect across. That's how it's going to be 6 long. The snakes that come like this leave behind a single cell. So either of these. So what we need to do is leave behind 2 cells, just as we saw before. Make this pattern with a U for the 6 unit snake. This then now isolates some options, I think, for the 4. Like, where can this 4 end? Well, it can't come up and over because it would require the end to be here. These ends actually need to extend out, so we've got some markings there. This 4 looks like it can come over and down, but we're going to run into some other constraints. So maybe let's look at the snake. This is 5. It's very soon to become 6. If it came to the cell, it would be 6 and touch a 6. So it never takes this cell. This 2 takes this cell, which means you've got a snake coming out here. This 4 now can't reach to this cell because it could be too large, so it's got to come straight down, finishes this way. That means we've got a 7 unit snake here and a 3 that's sufficiently packed this way. If this took, notice this is now an end. Sorry, it can't be an end, so it's got to come down. This is now 6 units, has to come one more to get to join to become 8. This is a 5 unit snake coming down. If this came left and down, it would end on an ineligible cell, so it's got to come this way instead. It's got a snake coming out this way, a snake coming out this way. If these join together, we'd have a 5 near a 5, so instead it's over here, and that end has to keep going for a 4 with a 7. So just using the X as no end cells throughout this whole grid, and particularly seeing how that packing gave some parity options, like this 3 for this 5, eventually for these 6s, like, where can this 6 end? Where can this 6 end? Where can this 4 end? Like, this kind of thinking worked throughout the grid and hopefully led to a very interesting solve. And for those who watched all the way to the end of the video, thanks for doing so. Hopefully you learned something from watching me get through this puzzle by Prasanna. Thanks, we'll see you again soon.